Remember, before you start solving this problem, heat exchange formula, there are two heat exchange formula, okay? The first one is Q equal to mass into latent heat. This formula we use when there is a state change. That means when ice melts into water or water freezes into ice or ice boils into steam or other reverse. Similarly, there is another formula, there is a second formula, and that formula is Q equal to mass into specific heat into change in temperature, final temperature minus initial temperature. Now, the second formula, Q equal to mc theta f minus theta I, or final temperature minus initial temperature. Use this formula when there is a heat absorption, there is a heat gain. That means the temperature rises. And if there is a loss of temperature, that means the body is basically cooling down, then you write Q equal to mass into specific heat into theta I minus theta f, while using the formula heat gain equal to heat loss. That means principle of calorimetry. So hope you enjoy the solution and do let me know in the comment section or DM me. The question says that there is a 2 gram steam at 100 degrees Celsius. It is mixed with 5 gram ice at minus 40 degrees Celsius in a calorimeter. We have to find out the final temperature. The latent heat of vaporization, specific heat of ice, specific heat of water, and latent heat of fusion of ice all are provided. So to solve this problem, you have to first understand then which one is a hot body and which one is a cold body. Obviously, steam is the hot body and the ice is the cold body. So steam is going to lose heat and the ice is going to absorb the heat or gain the heat, right? So first, steam at 100 degrees Celsius will lose heat to become steam at 100 degrees Celsius will lose heat to become 2 gram water at 100 degrees Celsius. So for this process, how much heat the steam has to lose? The steam has to lose 2 into 500 because latent heat of vaporization is given here as 500 calorie per gram. So this much heat steam has lost. Now, after losing this 1000 calorie of heat, steam has become what? Water at 100 degrees Celsius. Water at 100 degrees Celsius will further lose heat to become water at theta degrees Celsius. So for that equation, I'll write 2 into 1 into 100 minus theta. Remember, in case of heat loss, you write the initial temperature first, then the final temperature. Now, ice is of mass 5 gram and it is at minus 40 degrees Celsius. So this ice, after absorbing that heat the steam has lost, will now become ice at 0 degrees Celsius. So how much heat the ice must absorb to become ice at 0 degree Celsius? So for that equation will be mass of ice is 5, the specific heat is half, and final temperature is 0 and initial temperature is minus 40. Remember, in case of heat gain, you always write the final temperature first and then you write the initial temperature. Now this ice at 0 degrees Celsius will further absorb heat to become water at 0 degrees Celsius. So for that, it has to absorb 5 into 80 calorie of heat, which is 400 calorie of heat. Now after absorbing this heat, water is formed. How much water? 5 gram. Now that water will further absorb heat because steam is losing the heat. So that lost heat is absorbed by the water, and the water is now going to raise its temperature to become water at theta degree Celsius. Theta is the final temperature, this theta. So how much heat will water further absorb? 5 into 1 into theta minus 0. So the right hand side, the second bracket term is the heat gain, and the green color second bracket term is the heat lost. And the principle of calorimetry says that heat gain equal to heat loss. So using this equation, we have written this equation. Now once you solve this, so this is 1000, this is 200 minus 2 theta, this is equal to 40, 20, that means it is becoming 100 plus 400 plus 5 theta. So you have here 500 and you have here 1200. So if you do the side change, you get 700.
is equal to 7 theta. This implies theta is equal to how much? 100 degrees Celsius. So the final temperature of the mixture is 100 degrees Celsius, and finally it is total 7 gram of water at 100 degrees Celsius. So I hope that this basic rudimentary problem regarding calorimetry is okay for you. I will further solve much more complicated calorimetry problems in the coming videos. Thank you for watching. Tata, bye bye. See you in the next video.